So let's start the bootstrapping of worker 1, which will be the first worker node to be added into our Kubernetes cluster. So for that, we need to create certain configuration first on master 1 and provide the basic authorization configuration for that worker node. So first thing would be we need to create one configuration file and create some certificates for worker 1 node so that the worker 1 node should be able to authenticate or authorize itself in master nodes or controller nodes. So this is the file, and I'm creating those certificate. So what I'm doing in this step is I'm just creating one command, one file, which is OpenSSL worker1.cnf, which is a configuration file. I'm adding certain alternative names for worker 1, providing an IP address, and using this configuration file, I'm creating a key pair, and in the second command, I'm generating one certificate signing request, which is the CSR. And in third command, what I'm doing is I'm generating a worker1.crt using that worker1.csr. So we got the files generated for worker1, which will be worker1.key file and worker1.cert file. Let's move to the next step. And in this step, we just, as we already know, we have two master servers running into this demo cluster. As we do have two master servers running in our Kubernetes cluster, so we do have two API server instances running on those controller nodes, and we do have a load balancer uh, to do a round robin redirection or high availability redirection for those APIs. So we have to assign that load balancer variable once again. This is the IP of my load balancer virtual machine. So that variable is set in master once again. And now we have to create a kube config file using those certificates which we have recently generated for worker 1 node on our masters. So you can see we are just creating the configuration file, setting up certain cluster related permissions. We are using our signing authority certificate. We are providing our load balancer server listen address. It is the variable which we recently set it in our previous step. This is the IP, and here we are providing and setting the configuration set credentials for node authorizer. This is our worker node 1 which we are going to add into cluster, and these are the required or associated certificate file which we recently created for worker 1 and worker1.key, and this is the worker1.kubeconfig, and so on and so forth. So we are creating all those configurations. We are setting the context, we are setting the credentials, and let's execute this command. So it set it certain configuration in our Kubernetes cluster as we executed this in the master 1 node. Okay, so now as a result, we should get one worker 1 dot kubeconfig file. Let me quickly verify that. And here we do have that worker 1 dot kubeconfig file generated. Okay, let's move to the next step. And now we have to copy these private keys and kubeconfig file to our destination server, which is worker 1 in our case. So let's do the same. We are just executing the secure copy command for copying these files, which is worker1.cert, worker1.key, and worker1.kubeconfig, which we recently generated in our last steps. As we do have a passwordless SSH, we need not to provide any credentials, and we can see our files are copied 100% to the destination node. Okay, so let's move to the worker 1 now. So this is the worker 1 node, our destination where we just copied the file. So the first step here, we have to download the binaries from the official site. So there is a certain component like kubectl utility, kubeproxy component or Cubelet component, which is running on worker node. So we have to download the binaries from the official site. So we just need to execute a simple wget command, and it will download all those binaries. So it will take some time based upon your network bandwidth. Okay, so now we can see the binaries got downloaded successfully. So the next step, we have to create certain installation directories. So on our worker node 1, we have to create these directories. So I'm just executing simple mkdir command and creating all these directories so that I will copy and paste these downloaded binaries into these directories. Okay, these got created, and I need to provide these binaries executable permission and then move into the specific user local bin directory as we created. So here I'm just adding the executable rights for these three binaries and just moving them to the user local bin directory. Okay, and let's move to the configuration part now. When we say configuration, that means like configuration all these downloaded binaries one by one. So here in this command, I'm just going to moving. This is the host name variable. So once if you will echo this $hostname dot key, it will give you the output as in worker1 dot key and worker1 dot crt, which we recently generated in this demo. So if you have to do some automation and you have to add more number of nodes into cluster, then in that case you will use these kind of variables, and that will be randomly changed with the your available node list or whatsoever logic you wanted to apply. So let's move forward and execute this. So in this, these config files are moved to the specific directories. And now I have to create one kubelet config.yaml file with the default settings. And this is gonna create it in this directory var lib kubelet kubelet-config.yaml, and this is the default parameters. We are just adding the ca cert into the cert file, and we are adding just to avoid certain loops, we are adding this to the result.conf as well here. That's fine. So this got created. So let's move forward and then generate kubelet service. So for the kubelet service, I will use this command. So in this command, we will using the binaries which we recently downloaded. This is the basic structure for you'll get these all these commands in official Kubernetes documentation as well, and all these files which we generated in our last step. So let's move forward and generate that. So that service is also generated. Now what we have to do is we have to move to the next component, which is Kubernetes proxy. So what we have to do is we have to move this kubeproxy.kubeconfig file to the appropriate directory, which is kubeconfig directory under var lib kubeproxy location. Then we have to generate kubeproxy.config.yaml file and provide the cluster CIDR information like this. I'm just adding because I'm just providing the basic details. I'm just providing my cluster CIDR here. Nothing apart from that is important. And as the next step, what I'm going to do is I'm just going to create a kubeproxy.service. For that, I need to execute this command. It will give us the kubeproxy.service created. So in our last step, we have configured kubelet and kubeproxy components. So let's restart them in a batch. So this will be the command to restart all these components. And as we got output now, and we can see worker 1 is added status is not ready because we have not configured the networking till now. So as we already added the worker one into our Kubernetes cluster, it's time to move forward and add the another one, which is worker two. So for that, we will use the another approach as we discussed in this demo. So, so first step will be downloading the binaries from the official Kubernetes website. It will take some time, and the time depends upon your network bandwidth. Okay, so binaries got downloaded now on our worker 2 instance as well. So now we have to again create the required directories as we did in step 1 for worker node 1. So we need to create the required directories like this. Okay, and then we need to provide the executable permissions for these binary folders and move them to the appropriate location under user local bin directory. So we've also followed this step while we are adding our worker one node. Okay, so now let's add another step here. We need to copy the CS certificate to where lib Kubernetes directory. That is also true. And now what is difference is we need to create the bootstrap token to be used by a node, which is worker 2 in our case. So worker nodes Cubelets use those bootstrap tokens to invoke certificate API. So when we talk about this in detail, so worker Kubelet has to access the certificate API. They need to authenticate to the Kubernetes API server first. For this, we need a bootstrap token to be used by the kubelet. So bootstrap tokens take the form of a 6-character token ID followed by a 16 token secret separated by a dot. So which will be looks like this. And we do not, I'm just pasting it as a reference perspective only. This is the sample token ID for bootstrap. Bootstrap tokens are created as a secret in the kube system namespace. And the file we need to create is like this. So let me just do a control C here as we do not require it. And this will be the bootstrap token YAML file. We are providing the sample token IDs and token secrets and all those required stuff here. So that we need to create this bootstrap token YAML file on the master node with this information. It will create certain objects. And then we have to use the kubectl create command to use this YAML file which we recently created and generate the required secret. So we can see it generated secret bootstrap token with this created. Okay. So next thing here, we need to authorize worker Cubelets to this CS to create the CSR. So we need to authorize worker Cubelets to create CSR. So for that, we need to execute this command. This will be the command kubelet create cluster load bindings. Kubectl create cluster role bindings, create CSR for bootstrapping, and we are providing these information. Bootstrapping is created, and so as a next step, we have to authorize worker kubelets to approve CSR. So in previous step, we created a CSR. In this step, we are performing certain things to approve that CSR. So in this next step, we are authorizing worker kubelets to auto-renew certificates on expiring. So whenever they expire, they should auto-renew them. That cluster role binding RBAC is created now. Okay, and the next step will be configure kubelets to TLS bootstrap. So this is the TLS bootstrap method we are using. So we have to execute these commands in worker 2 node. So we have to move to worker 2 now. and do I just clear screen and execute these things, and they all configuration is set. What we're doing is we are just creating configurations and providing the values. You can pause this video and refer these commands in detail. And as a next step, we will create a kubelet config file, and this will be the command to create that kubelet config.yaml file. So as a next step, we just need to configure kubelet service, and for that we will create this kubelet.service util command. So kubelet service got created for worker 2. Now we will configure a Kubernetes proxy. We will just move kubeproxy kubeconfig file to the appropriate directory. And next step, we will create kubeproxy config YAML configuration file. We will cat it. And add the required parameters. And next step will be we need to create kubeproxy.service now. And this will be the command to create kube-proxy.service. Now we have to restart the services which we downloaded and configured, Cubelet and kubeproxy. So those services got created, symlinks got created. Let me check the CSR because it's a TLS boot, because it is a TLS Bootstrap bootloader. Oh, let me check the CSR now. So kubectl get CSR will be the command on the master one. And we can see this worker 2 node authorization CSR is pending. So we have to approve it. So for that, the command will be kubectl certificate approve and the certificate name. And again, we will execute this command to check if it is got approved, and we can see it is approved now. Okay, so just for the verification, let's see the same command kubectl get nodes to check if this node is successfully attached and visible into kubectl get nodes commands output. And yes, we can see both worker 1 and worker 2 is got added into the cluster. So configuring kubectl for remote access. So for that, we need to generate the admin Kubernetes configuration file so that we will be able to authenticate ourselves from the admin access, admin privileges. We have to create one, we need to set certain configuration on our master one node here. We have created a variable assigned the load balancer address, which is our load balancer VM's address, and all these default configurations. So it sets the cluster Kubernetes the hard way, user admin, context, switch to context is got created. As a next step, let's check the component status, kubectl get component status command, and see if health is okay for the rest of the components. Yes, etcd healthy, etcd 0 healthy, controller is healthy, and scheduler is healthy. So we are all good. So now we have to move forward and deploy the networking so that we can see our nodes, which is worker 1 and worker 2 using kubectl get nodes command are not ready state. So they are not ready to accommodate any pod or any application. So we have to provide or configure certain networking, software defined networking. So there are various networking CNI providers in the market, and in this demonstration we are using Wave. So while we are configuring Wave networking CNI for our cluster on worker 1 and worker 2, we need to download this binary. So I'm downloading it on worker 1 and worker 2, both of the nodes. And once it is downloaded, we have to extract this archive because we are downloading it into TZZ format. So it's an archive format. So once it is downloaded successfully, we have to extract it into the OPT CNI bin directory. So this will be the command. And same we have to do it for worker 2. And then we just need to use this command to deploy the wave network on master 1. So we have to move to master 1. We have to execute this command kubectl apply, and we just need to enter, and it will configure those downloaded binaries and created the required objects using that template file. So they are still in container creating status. So they are getting created. 0.2 means there are two containers in this pod. So both of the containers should become successfully. They are still creating. So first time when you are trying to deploy any application or any pod, it will take some time because it will take some time to download the image locally, because every pod, if it is a system application or your business application, everything runs on the images. So currently we do not have any local copy of this wave networking images. So it is downloading or fetching it from the authorized site. And that is why container creating status is taking that much long. So that majorly occupied by the image download. We can see one pod comes up successfully. And if we wanted to see where this pod is sitting, so we can also check using kubectl get pods hyphen o white command, and the hyphen n is to provide the project name, which is cube system in this case. And we will see both of the pods are running now, and this is running on worker 1, and this same pod replica is running on worker 2. So we are all good now. Our pods are running, our networking is configured successfully. So we do have, so next demonstration, we will deploy certain images into our Kubernetes cluster. Thank you for watching this video. I would request you all to subscribe my channel and like the video.